All right, so today I'll be looking at the principles of composting. So I'll touch a little bit on what is composting, and I'll go into, certain important factors that you have to consider when you're making a compost, and also look at utilizing compost in terms of supplying nutrients to your soil as well as suppressing diseases. Sorry, I just saw something come up on the screen. All right. So everybody's seeing the screen and we're ready to start, ready to go?
Yes.
Right.
Yes.
Excellent. So we say compost is like money. It's not worth anything unless you spread it around, meaning that you can't hoard this compost or have the compost there for a long time. We have to utilize the compost for it to add value, especially to add value to our soils and to the crops that will be grown in our soils. Now, before I move forward, one of the biggest misconception that we have out there about composting is that composting is basically when we take some of our organic matter or waste material, or grass or manure, we just put it together over in a corner and we see that material start to break down, and sometimes months before it actually breaks down. And we say, yes, that is a compost pile. That is my compost that I'm adding to my garden. That is the compost that I'm adding to my farm, the land that I farm on. But what I want to clarify here before we move on is the difference between decomposition, right, of organic material. And when I mention organic material now, we're speaking about all that waste that we will utilize in the composting process versus stabilization of organic materials. So decomposition occurs naturally. If you walk in the forest or walk somewhere and we have some residue leaf or something, you're going to see it break down over time. You're going to see it turn to that dark matter over time. And so it is a natural process. However, it is a slow and uncontrolled process. There's no human intervention. There is just the human natural environmental conditions taking place and the material just breaking down. And so you cannot guarantee that the material will be free from certain pathogens or will even be in a state where it will be beneficial for you to use on your farms or in your gardens. Versus stabilization of organic materials. When we speak about stabilization of organic matter, we're speaking now about human intervention. So we pay a close attention to the pile or to the organic matter that we're decomposing or breaking down in that compost pile. We monitor it routinely. And so what happens is that you get an accelerated process in terms of the breakdown of the material, and we get higher quality material at the end with better sanitation. So there are two processes, and when we say aerobic, two processes that basically utilize oxygen to drive the breakdown of the material. And these two processes are thermophilic composting, or what we know commonly as hot composting, and vermicomposting, and that's the one that involves the worms. We're not going to speak about vermicomposting today. What we're going to speak about is hot composting or thermophilic composting. And both these composts can also make byproducts or further byproducts, which are known as compost teas, or what we call liquid extracts that we can also use on our plants. So then what is composting? Composting really is the controlled, and I want you to note the word controlled, meaning that you have that ability to control aspects of the process and monitor it. So the controlled breakdown of organic materials or feedstock or waste in a predominantly aerobic, meaning oxygenated, a lot of oxygen, a lot of air environment under conditions that generate high temperatures by the microbes. So at the end, we get what is known as a stabilized product. And I'm going to be driving this term stabilize, and I'm going to be explaining it as we go along in the presentation. We also get a product that is what we call pathogen safe, meaning that we're not expecting any harmful pathogen, particularly human or even plant pathogens, to be present in that material. And we also have it being free of weed seeds, meaning that there are no more viable weed seeds in the compost at the end, in the stable product, right? And it has a dirt-like property, right, at the end. So that is what we call composting: controlled, oxygenated, high temperature, heat, stable product at the end. So why compost? There are many reasons for composting, and I'm sure when my colleague Mario goes on, he's going to speak about other reasons for why we compost. But it's a waste treatment technology, and we generate waste every day. As a matter of fact, in our countries in the Caribbean, at least over 40% of the material that we send to the landfill, or even in our farms, are organic materials, are materials that can be composted. However, we don't separate our waste. So sometimes it's a bit difficult. It also helps to prevent environmental pollution, because you can imagine when you have those things rotting like your vegetables and all of these things, it has a scent, right? Sometimes you have a little cockroach here, a little rat there. So it helps, it's a method to control or prevent or reduce environmental pollution, right? It reduces waste that we send to the landfills, and we pass the landfills, you know, in Trinidad, Beetham, you know, in Jamaica, Riverton. You know, we've passed the landfills and we see the issues that we have with our landfills in the Caribbean, right? And also it saves money. So it's a low-cost process, low operational cost, simple technology that you and I can benefit from, and others. So I'm going to be speaking briefly about setting up compost, or setting up a compost pile. Now, there are many different ways to set up a compost pile. And there are many different methods of hot composting, right? And I'm not going to get in that because my colleague is going to touch on that a bit. However, the first thing that I want in a very simple way is that we have to transfer the material. We have to look at the materials that we have around us, right? And you know, we know that some of the material that we can use sometimes is our manure, right? Or grass, or weeds, or vegetable waste, and so forth and so on. So we have to transfer the material, and in its simplest form, we can use a wheelbarrow to transfer this material. We can use a pickup, a front end loader, which is a tractor, or a dump truck, and that depends on the scale of the exercise to which you're carrying out. And then after that, we look at particle size reduction, and we're going to speak about why we're reducing the particle size when we move forward. So we can use a grinder. So in the image that you're seeing above here, you're seeing some grass. I believe this was Johnson grass, right? Being grinded up, right? To a particle size that is probably less than 2 inches. And we also see below where we have some manure that would have pounded and that we're sieving, right? To pass through a particular sieve, right? So we have smaller particles. We can use a chipper for wood chips. And we can also use a lawnmower for our grasses to get them to a different particle size that we can utilize in our compost to get a better output in our product. And then the last major thing that I want to cover in mixing or setting up your compost is the mixing process. And we start very simple from a shovel in terms of our manual activities. A hay fork sometimes to turn the mixture, right? A batch mixer that probably rotates automatically, or a rotating mixing drum, or a bucket loader, right? Which is basically a tractor that is mixing, that has the front end loader. We also have the water adding system as well too, when we're mixing. So we can have a hose, we're near to a water source, or we utilize a water truck. Again, it depends on the scale. But in its simplest form, we collect and transfer the material to a flat surface. We reduce the particle size, and then we carry out our mixing activities. So there are a few critical things that we have to consider and look at when we're making our compost. And the first one that I want to discuss is the carbon to nitrogen ratio. And you might be wondering, what is carbon to nitrogen ratio? Where this whole heap of science come from? But really, in its simplest form, again, when we speak about carbon, we're speaking about the brown feedstock or the dry feedstock, right? And the availability of carbon, it depends on the size of the particle. It also depends on the lignin. So, you know, when you have those branches that very thick and hard to break, that dictates the availability of the carbon. And who do we want the carbon to be available to? We want the carbon to be available to the microorganisms, because they are the driving force in the composting process. And so the carbon acts as the energy source for the microbes. Similarly to us, how when we eat our yam, banana, or carbs, that acts as the energy source for us to carry out our activities or our grow food. This is the same thing that when we look at carbon, and its use or its importance to microorganisms. Then we have nitrogen. We consider nitrogen to be our green feedstock or wet feedstock. And the reason why we say it's wet, because think about if you cut some Johnson grass or some grass. When it is wet or when it is green, it will be wet. And that means that it has what? Some moisture inside of it. And as soon as that moisture dries out, it becomes brown or it becomes dry, right? And so our nitrogen feedstock is what we call our green feedstock or wet feedstock. And again, its availability depends on the particle size, which is why we grind them or we break them down into smaller size before mixing. And nitrogen is linked to protein. So when we think about nitrogen, we think about now in terms of us, the meat that we eat. That is very important. We can't eat the yam and banana alone without having the meat. And it's a similar thing here. The microbes require the protein for them to grow or for them to carry out their activity. And so a balance between the carbon to nitrogen is very important for the microbial activity, for them to start to reproduce, for them to increase in population, and for them to start to do what they have to do and break down the material so that we get something that is beneficial at the end. But what we should know is that when we look at a ratio of carbon to nitrogen, in a brown material, we will have some amount of nitrogen. And in a green material, we will have our green feedstock, we will have some amount of carbon. So basically what we're saying is that there is more carbon or in the brown feedstock relative to the nitrogen. And there is more nitrogen relative to the carbon in the green feedstock. And so when we have a high C to N ratio, and always say C to N ratio, you want to think about, let's say we have some pigtail buckets or 5-gallon buckets. We're thinking about 10 parts or 20 parts of the 5-gallon buckets with brown feedstock to about 5 parts or 5 of the 5-gallon buckets of green feedstock. That is what we speak about, a ratio. That's what we're speaking about. And so when we have a high C to N ratio or carbon to nitrogen ratio, what we tend to have, that means we put it up or we pack it up with a lot of brown material. We tend to have slow decomposition. And we have limited microbial activity. And remember, we say the microbes are the driving force. When we have low C to N ratio now, meaning that we have a higher amount of nitrogen relative to carbon, what we start to have is that we have loss of ammonia, right? And that results in that gas, that scent that we don't really like. And ammonia, you know, it forms a part of the nutrient cycle or the nutrient within the composting system. And so when we have a lot of loss of ammonia, we tend to have loss of nutrient, particularly nitrogen. And so that is why that balance between the carbon, the energy, and the nitrogen, which is the protein, is very important for microorganisms. And then now we look at another component, which is porosity. And what is porosity? When we think about porosity, think about the pores. Think about when you go to the beach and you have a bucket of sand. And when you have these little sand grains, you have little spaces in between the sand grains. That is what we call porosity or the pore. And so when we look at the porosity, we can have either water filling the pores or air filling the pores. But there has to be a balance between the two, between water and air. We generally want to maintain moisture between 40 to 60%. And you might ask yourself, what is 40 to 60%? How I'm going to tell that? And I'm going to explain to you how you can, know if it's 40 to 60%, which is of the weight. And then we don't want too much water, because guess what? If we have too much water, we're going to have compaction. And when we have the material compacting on top of each other, we're not going to have any spaces for what? For airflow. And that is going to affect the composting process. And then if we have too little water and it is very dry, then we will have very little microbial activity. Microbes now go to nothing. And then the breakdown is going to be slow. And so one of the things that we do to ensure that we have adequate amount of water is what is known as a squeeze test. When you take up a handful of compost or the mixed material, right, that you would have combined, and when you squeeze it between your hands, if when you open your hands, it crumbles and fall apart, it tells you that the material is too dry. If when you squeeze it, you have a lot of water running out of your hands, it tells you that it is too wet. And so what you want is that when you squeeze it, it kind of forms a ball and there's a little bit of water running between your knuckles. Now, sometimes because of the nature of the material, you might have to add a lot of water because you're realizing it comes like you're mixing, we call it plant cement. You're mixing and mixing and mixing, and the things still seem like it's dry. And so depending on the system that you're using and where you're setting it up, the excess water, especially because of the pores, can sometimes drain, and you get it to a point where the moisture is between 40 to 60%. The air is very important, and airflow is needed for microbial respiration. So yes, the microbes do respire, and I'm going to tell you the importance of that respiration. Just like how we respire and we breathe in and out, take in oxygen, let out carbon dioxide, among other things. The airflow also reduces odor, because you can imagine, just like if you have wet clothes and you pile up the wet clothes in your house, it smells bad, right? It have a little frownsy scent. Now the airflow, if you don't have airflow in the compost or pockets where air can flow, where it's not filled with a lot of water, you're gonna have some, some odors that are not pleasant to you. And then the rate of aeration, meaning that how often you turn, how often do you introduce air to the pile, that affects the temperature. And sometimes if the temperature is too high, where it can affect microorganisms, you would want to now introduce some air to kind of reduce that temperature. And so one of the methods that we use oftentimes when we have a lot of wet waste, right, and our waste that are very liquidy, is that we add bulking material. And these bulking material are represented as like sawdust or wood chips, right? Material that are not so easy to break down as well, right? Have a lot of lignin, hard to break down. These materials, because of the nature of them, they create pockets where air can flow within the compost, all right? So these two dynamics between water and air and the balance within the pores are very important to ensure that the composting process is kickstarted and it goes forward. And then another important component is temperature and pile heating. I'm sure you have heard that when we talk about hot composting, we say we're cooking the compost. And if you look here, we have a little investor system, a little 55-gallon drum that we, you can turn, without using a fork. And if you look at the thermometer, the long stem thermometer in there, you're seeing 60.7 degrees Celsius. And that means that it's very hot, or the center of the pile is very hot. And so compost, or the temperatures within compost, generally, once it's mixed properly, we have the appropriate carbon and nitrogen for the microorganisms to start to reproduce and increase in population. We have the right balance of air and water within the pores. We mix it properly and we have it in a nice little pile. The compost temperatures would increase rapidly within 24 to 48 hours, above 45 degrees Celsius. And depending on the height of the pile or how big the pile is, this can sometimes go close to even 100 degrees Celsius. And that is in the initial stage of the composting. And so what is happening there is that the microbes are respiring. And a byproduct of respiration is heat. You ever realize that when you're in a room together with a lot of persons, no AC, you start to feel hot? That is because you're respiring and your body is giving off that heat. And so similarly, when these microbes now build up in population and they start to act and eat the material and break it down and all of these things, they are respiring and they are producing heat. And this heat is cooking the compost pile and is also serving a very important function in terms of denaturing the weed seeds and also reducing the pathogen level to a threshold that is no longer harmful, right? And so generally we want to have temperatures above 45 degrees Celsius for continuously, depending on the pile size, for at least 5 consecutive days. And even longer again, depending on the pile size and the type of material that you're composting. Also, compost can self-insulate. So because you're stocking everything on top of each other, just as if you're stocking, if a lot of you in the room, there's gonna be that insulation of heat. So because of the materials stocked on top of each other, you can have that sustained temperature. And as pile temperature decreases, which it will, and I'll explain later on, the breakdown also decreases. Because guess what's happening now? The microbes don't have enough food now, And so the microbial population starts to reduce a little bit. And so after the reduction in the microbial population, they also start to feed less. And so the temperature and the respiration and the heat also decreases. And so temperature is affected by the physical and biological composition of the compost. So how the shape of the material, the biology of the material, the availability of nutrients. We speak about carbon and nitrogen, the level of moisture, the structure of the pile. And we say the structure of the pile, we're speaking about the bulk density, the particle size. Because you see, if the particle size is smaller, it means that the microbe can act on it. Just think about when you're eating something or giving something to a baby. If the food is crushed or smaller, it is easy to digest, it is easy to consume. And similarly, when the material that you're breaking down is a little bit smaller, not too small that it does form a flat compaction, but small enough where the microbes can actually act on the surface and eat it and break it down. Also affected by the rate of aeration, the size of the pile, and most importantly, the surrounding environment. So if it's windy, if it is rainy, it will also affect the temperature. Another important thing to consider is pH. And somebody might ask, what is pH? pH is simple, how acidic or how basic something is, how alkaline something is. And I put this little chart on the left-hand side to show you some little household things that you can relate to being alkaline or being acidic. So at the acidic level, you realize that lime juice and vinegar are very acidic. Grapefruit juice, coffee is a bit acidic. But then now when we move now to, being alkaline, we start to look at the baking soda being alkaline, the bleach being alkaline and stuff like that, right? And we also have neutral, which is at 7, which means that, it's neither alkaline or acidic. And so the pH literally affects, you ever hear them tell you drink alkaline water, not acidic water? Because it affects us similarly. The pH affects microbial activity. And affects
but I have a title on a piece of rope. Get me.
And so usually pH rises and then falls, right? So in the beginning, when you start off the composting process, the pH is going to increase and then it's going to fall. And so what we generally want is a pH between 5.5 and 8.5 to start off with. And you see this little machine that you're seeing a picture of, that is a pH meter. This might be a little complex one, but you have very simple ones, very reasonable ones that you can get on Amazon for about $40, $30 that can do the same thing and tell you the range of your pH, how acidic or how basic something is. Now, if you're starting off with materials that are very acidic, feedstocks that are very acidic, such as vegetable waste, sometimes you might want to add liming products. And liming products like wood ash, because wood ash is generally a bit alkaline, to kind of balance off the pH so that you get that nice kickstart in your compost. And what will happen is that if your pH is too acidic, meaning that it's down here like the lemon juice and the vinegar, it can affect the microorganisms and they will die. No activity, and you'll have that scent occurring in the compost pile. And also, you remember we spoke about ammonia and that gas and how it affects nitrogen. If the pH is too high, we will have a lot of ammonia and that scent occurring, and we'll lose a lot of the nitrogen and the nutrition or the nutritive value of the compost, right? And we don't want that. And then we have something called soluble salt content. Think about the table salt that you normally have, but in this case, the soluble salt would be things like your magnesium, your potassium, your calcium, all of these nutrients that the plant will generally use come together. And so generally, the soluble salt content is reported in what we call decisiemens per meter, but don't worry about that. But in this range or in this value, just like how we say we are 5 feet, this is the unit that is used to measure salt or the soluble salt content. And generally, in a finished compost, because of the type of material that you start with, such as manure and all of these things, you might have a EC or a soluble salt content of 5 to 15 decisiemens per meter. So within that 5 to 15, what we know is that that is very high salt. And you can imagine when you eat some meat or you eat some food and it's very salty, you want some water, or your tongue is scorched. And similarly, we see here, when you look at these plants here, that would have been exposed to high salt compost. You see how they're melting away and sometimes burning, right? And so we want our salt to be less than 5. And that is preferred when we're going into crop production. And even when we're doing seedlings, we want it to be even lower, right? And that is one of the considerations or the things you have to think about when you're doing hot composting. You have to monitor, or you probably have to mix it with like some pro mix or some salt, because the salt content might be a bit high. Or you might have to consider the material that you're mixing because of the how salty these materials are. generally. And some of these salts are essential to plant nutrients, and they affect seed germination, they affect plant growth, such as the root and the shoot growth. And here we have a little machine called an EC meter that can measure salt. And similarly, you can get this on Amazon for a very reasonable cost to monitor your salt, right? Especially if you're gonna have an end use for your compost. And you know, we've been talking about microorganisms and the importance of microbes in the composting process. And one of the material that really provides these microbes, what we call our seeding material, we'll call it seed because it just gives a lot of microbes, is our manure. Our manure naturally gives a lot of microbes to kickstart the composting process. And that is why it's such a nice substrate to use, and also a difficult substrate sometimes if you don't know what you're doing. And so the microbes, generally we're looking at, this is a bacteria. So this is many bacteria together on a plate, on a nutrient plate with some nutrient growing. And here we see some fungi on the plate as well growing. And you have other microorganisms that are involved in the composting process. But these two help to break down. They are the ones that help to break down the material and very important in the process. And so they need the nutrients such as the carbon and the nitrogen that we spoke about, right? For the energy and the protein to carry out the activity. They need oxygen, so they need the porosity. Remember, we're speaking about the porosity and the pores. They need the air to breathe, to carry out respiration so that they can live. You need to manage temperature because if it's too high, it can affect them from functioning. So that is why sometimes you have to turn your pile. And you also need the moisture because the moisture helps them to, you know, to move and to carry out certain activities. And most importantly, time. Because over time, these microbes will increase in population, increase in their activity. And so that is why time is very important in the composting process. And so really and truly what we just discussed a while ago is our nutrients, carbon and nitrogen. And we have target range, 20 to 1, 40 to 1. What does that mean? In my layman term, I love to say 3 parts of brown, 3 to 5 parts of brown to 1 part of green. And remember, we say our browns are our carbon. When we have that blend generally, and we say 3 parts, you're gonna obviously scale up. It means if I have 3 pigtail buckets, I use 3 pigtail buckets of my brown to 1 pigtail bucket of my green. And remember, I said that the brown will have a little bit of nitrogen in it, you know, and the green will have a little bit of carbon. So that is why you don't necessarily have this ratio or when you're when you're mixing. But if you're supposed to test the material, this is the ratio generally that they're saying that composting will occur in. But we're not saying that composting cannot occur outside of these limits because it can and it has. The moisture content we spoke about and all of these other things we spoke about. What is bulk density? Bulk density is really when we look at the mass. So the weight of something in the bucket. If we put a bunch of leaf in a bucket, it's going to be light versus if we put soil in the bucket. And so that is what we mentioned in terms of bulk density, the weight of something in the volume, in the bucket, the 5-gallon bucket. And what we're saying is that generally when we mix our compost and we have our mix, if we take up that bucket and we weigh it on a scale, it should be less than 25 pounds, right? The material inside of it, for us to have an idea as a rule of thumb that, listen, well, bulk density is okay. We're not going to have too much compaction without no air, no pore space for air to flow, etc. And so really, when we look at the composting process, what we're seeing is that we're inputting some raw organic matter, feedstock, waste. We have some nutrients in that organic matter as well. We add our water. We have our microorganisms coming from our organic matter, such as our compost. And then when we mix everything based on what we would have said, and we have oxygen and in the air, in the pore spaces, etc., we start to have what? Water being lost. We start to have heat because the microbes, you know, producing heat. And through the respiration, we have carbon dioxide being released. And at the end of the process, what we have is stable. So we'll come back to that word stable, stable organic matter, stable compost that still have nutrients, but these nutrients now are more available.
And she's coming back.
And when we say that the nutrients are more available to the plants, think about it this way. When you have the organic matter, the waste, that waste really and truly, the nutrient lock inside of the tissue. It lock inside, the plant can't access it. The plant can only access available forms. And so what the microbes do for you in the composting process is that they convert that nutrient that the plant can't access to a form that the plants can access. So the minerals over here are more accessible by the plants versus over here when we start. Then we have some water and we have more beneficial microbes in the stable organic matter.
Hi, Brian. If we could start wrapping up a bit.
Yes, ma'am, no problem.
Thank you.
And so when we look now right here, what we're seeing is that we can simply monitor the composting process. How? Temperature is the simplest way. At the beginning, the temperature rises, and then afterwards it drops down, right? And therefore, when it starts to drop down, that is when our compost is becoming stable or mature. And now I'll give you the answer. What is stability? Stability is when the compost or the decomposition has slowed. So meaning that the microorganisms don't have much more food or available food. So them kind of slow down in terms of how much breakdown they're doing, right? And then now the mature compost, right, would be now that it really has decomposed. More plant nutrients are available. And most importantly, harmful substances would have been reduced, right? And so that, when we talk about maturity, we generally do what is known as a germination assessment. You see some mix here, some solution, you see the plants growing, and you also see the seedlings growing in the compost. That is what you use to determine how mature your compost is. But stability, you would realize that your temperature would have fallen. And so you see it here, the difference when we start and when we end. And we also can use that compost to make compost tea, which is basically a liquid extract. Sometimes we can't travel with that bulky compost. Sometimes we don't have enough, but we can put it in, ferment it into some water, and this will have some nutrients and beneficial organisms that you can use. And it can be used for disease suppression and so forth. And so depending on how mature your compost is, you have different uses for your compost.